The universe is a vast and mysterious expanse that encompasses everything we know and experience. It is the totality of all matter, energy, space, and time. As far as we know, the universe began with the Big Bang approximately 13.8 billion years ago. This cosmic event marked the rapid expansion of space and the birth of all known physical laws. The universe is unimaginably large, stretching over billions of light years. It contains countless galaxies, each made up of billions or even trillions of stars, along with various celestial objects such as planets, asteroids, comets, and black holes. Our own galaxy, the Milky Way, is just one among billions. Despite its immense size, the universe is constantly evolving. Galaxies move and collide, stars are born and die, and new structures form over cosmic timescales. Scientists have been studying the universe for centuries, and our understanding has grown through observations, experiments, and theoretical models. One of the most fascinating concepts in cosmology is the idea of dark matter and dark energy. These elusive substances, which cannot be directly detected, are believed to make up the majority of the universe's mass and energy. They play a crucial role in the evolution and dynamics of the cosmos, influencing the formation of galaxies and the overall expansion of the universe. The universe is also governed by fundamental forces such as gravity, electromagnetism, and the strong and weak nuclear forces. These forces dictate how matter and energy interact on both the cosmic and quantum scales, shaping the structure and behavior of the universe at every level. Throughout history, humans have looked up at the night sky with a sense of wonder and curiosity. The study of the universe has not only deepened our understanding of the cosmos, but also raised profound philosophical and existential questions about our place in the grand scheme of things. As our exploration of space continues, through missions to other planets, telescopes observing distant galaxies, and experiments probing the fundamental nature of the universe, we hope to unravel important secrets. The universe remains an endless source of fascination, pushing the boundaries of our knowledge and inspiring us to continue exploring its vastness.
Planets of the solar system. Description, composition, and interesting facts. The solar system is an amazing and diverse place, consisting of 18 planets and many other celestial bodies. In this report, we will study each planet in our solar system, consider their composition, distance from the Sun, and some interesting facts about them. 1. Mercury. Mercury is the closest planet to the Sun and the smallest planet in the solar system. It consists mainly of rocks and metals such as iron and nickel. The distance from Mercury to the Sun is approximately 57.9 million kilometers. Interesting fact: despite its proximity to the Sun, Mercury can be very cold on its surface, as it has little to no atmosphere to retain heat. 2. Venus. Venus is the second planet from the Sun and the most Earth-like in size. Its atmosphere consists mainly of carbon dioxide, strongly heated by the greenhouse effect. Venus is known for its dense cloud cover, which is mostly sulfuric acid. The distance from Venus to the Sun is about 108.2 million kilometers. Fun fact: Venus is the hottest planet in the solar system, with temperatures reaching around 460 degrees Celsius. 3. Ground. Earth is the third planet from the Sun and our home. It has unique conditions that allow life to exist thanks to the right temperature, atmosphere, and the presence of water. The Earth is composed mainly of silicate rocks and contains oceans, rivers, and an atmosphere composed primarily of nitrogen and oxygen. The distance from the Earth to the Sun is about 149.6 million kilometers. Interesting fact: the Earth is the only planet known to us inhabited by a variety of life. 4. Mars. Mars is the fourth planet from the Sun and is known as the red planet because of its coloration. Its surface consists mainly of sand dunes, mountains, and craters. Mars also has an atmosphere, but it is much thinner and drier than Earth's atmosphere. The distance from Mars to the Sun is about 227.9 million kilometers. Interesting fact: Mars has the highest volcanic mountain in the solar system, Olympus Mons, which is also the highest mountain in comparison to its surrounding terrain. 5. Jupiter. Jupiter is the fifth planet from the Sun and the largest planet in the solar system. It consists mainly of gases, predominantly hydrogen and helium. Jupiter is also known for its powerful atmospheric storms, the most famous of which is the Great Red Spot. The distance from Jupiter to the Sun is about 778.3 million kilometers. Fun fact: Jupiter has the largest moon system in the solar system, including its largest moon, Ganymede, which is the largest moon in the solar system. 6. Saturn. Saturn is the sixth planet from the Sun and has a famous ring system made up of ice and rock materials. The planet itself is composed of gases, predominantly hydrogen and helium, similar to Jupiter. The distance from Saturn to the Sun is about 1 billion kilometers. Fun fact: Saturn has many moons, nicknames, but the most famous of them is Titan, which has an atmosphere and liquid lakes on its surface. 7. Uranus. Uranus is the seventh planet from the Sun and is distinguished by its unusual position. Unlike other planets, Uranus rotates on its axis, which is almost lying on its side. It consists mainly of ice and gases such as hydrogen and helium. The distance from Uranus to the Sun is about 2.9 billion kilometers. Interesting fact: Uranus has a system of rings, although they are much thinner and less visible than those of Saturn. 8. Neptune. Neptune is the eighth and farthest planet from the Sun. It also consists of ice and gases, mainly hydrogen and helium. Neptune is known for its strong winds and storms in the atmosphere. The distance from Neptune to the Sun is about 4.5 billion kilometers. Fun fact: Neptune is a giant planet similar to Jupiter and Saturn, and it also has a ring system that was discovered in 1989 by the Voyager 2 space telescope. Each planet in the solar system has its own characteristics, composition, and place in relation to the Sun. They present unique opportunities for our research and surprise us with their diverse nature. The study of these planets helps us better understand our place in the universe and develop our knowledge of the cosmos and life. Many planets in the solar system have been explored using interplanetary missions and spacecraft. 1. Mercury projects. The Mariner 10 mission in 1974 was the first to fly past Mercury, taking several pictures of its surface. More recent missions: NASA's Messenger, Mercury surface, space environment, geochemistry, and ranging mission, launched in 2004 and completed in 2015, orbited Mercury and collected detailed data on its surface, atmosphere, and magnetosphere. 2. Venus projects. The USA's Venera 7 mission in 1970 was the first successful soft landing on the surface of Venus. The Venera 9 mission in 1975 transmitted photographs of the planet's surface for the first time. More recent missions: the European Space Agency's ESA Venus Express mission, launched in 2005, has conducted a detailed survey of Venus's atmosphere. The Akatsuki mission of the Japan Space Agency, JAXA, launched in 2010, focused on studying the atmospheric conditions and climate of Venus. 3. Mars projects. Many missions to Mars have been sent since the 1960s. Some notable missions include Mariner 4, the first spacecraft to fly past Mars in 1965, and Viking 1 and 2, the first missions to land on Mars in 1976. More recent missions. Some of the recent missions include Mars Pathfinder, Mars Exploration Rovers, Spirit and Opportunity, Mars Science Laboratory, Curiosity, and the ESA ExoMars and NASA InSight missions that continue to explore Mars. 4. Jupiter projects. Mission Pioneer 10 and Pioneer 11 in 1973 were the first missions flying past Jupiter and transmitting data on its atmosphere and magnetic field. More recent missions: the Voyager missions, Voyager 1 and Voyager 2, in 1979 provided detailed images and data on Jupiter and its moons. NASA's Galileo mission, launched in 1989, has studied Jupiter and its moons for a long time and has provided valuable data on their composition and geology. 5. Saturn projects. The Pioneer 11 mission in 1979 was the first mission to fly past Saturn and send detailed images of its atmosphere and rings. More recent missions: the Voyager missions, Voyager 1 and Voyager 2, also provided unique images of Saturn, its rings, and moons. The NASA Cassini-Huygens mission, launched in 1997 and ended in 2017, has been exploring Saturn, its atmosphere, rings, and moons for a long time, including a detailed study of Titan. 6. Uranus. The Voyager 2 mission in 1986 was the only mission to fly past Uranus and provide the first detailed images of its atmosphere and moons. 7. Neptune. The Voyager 2 mission in 1989 was the only mission to fly past Neptune and provide valuable data on its atmosphere, rings, and moons. All of these missions have provided us with unique and valuable data on the planets of the solar system, and some of them continue to explore and send out new missions to expand our knowledge of these amazing worlds. Black holes, concealed celestial objects. Contrary to their name, black holes are not truly black. They represent regions in space where gravity's pull is so intense that even light, the fastest entity in the universe, cannot escape. As a result, black holes are deemed invisible. Despite their inability to be observed directly, we can infer their existence through various methods based on their characteristics, which we will explore further in this article. For centuries, scientists have grappled with unraveling the identity of black holes. In 1916, Carl Schwarzschild discovered the first modern solution of general relativity that described a black hole. However, it was not until David Finkelstein's publication in 1958 that it was interpreted as a region of space from which nothing can escape. The formation of black holes. Black holes are born from the remnants of massive stars. Stars with a mass greater than 3 times that of our Sun have the potential to form a black hole. Stars begin their life as hydrogen atoms, collapsing from immense gas clouds due to their own gravitational force. Through nuclear fusion in their core, hydrogen atoms combine to form helium, generating heat and radiation that counterbalance gravity's pull. A delicate equilibrium between these opposing forces is required for a star to survive. In the core, helium fusion can further progress to heavier elements such as carbon, oxygen, neon, silicon, magnesium, sulfur, and iron. However, iron cannot undergo fusion, leading to the cessation of radiation and heat generation. With the internal pushing force absent, the balance is disrupted, causing the star to collapse under its own gravity. Within a fraction of a second, the core becomes densely packed, merging protons and electrons to form neutrons. The core's temperature soars to billions of degrees, resulting in a supernova explosion. The leftover core material can then form either a neutron star or a black hole, depending on the mass of the original star. The size spectrum of black holes. Black holes exist in various sizes, categorized as follows: primordial, miniature. These are the smallest type of black holes, with sizes comparable to a single atom but possessing the mass of a large mountain. Stellar black holes are the most common medium-sized black holes. Their mass can be up to 20 times greater than that of the Sun, fitting within a sphere with a diameter of approximately 10 miles. Intermediate. This category includes black holes that are larger than stellar black holes but smaller than supermassive black holes. Supermassive black holes are the largest known black holes. Their mass can exceed that of 1,000,000 suns combined, and their diameter is comparable to the size of our solar system. It is widely believed that every large galaxy harbors a supermassive black hole at its core. Understanding black hole types. There are 2 primary types of black holes: non-rotating and rotating black holes. Schwarzschild, non-rotating black hole. This type of black hole, often referred to as a Schwarzschild black hole, features a singularity and an event horizon. The singularity represents the center where all the star's mass is concentrated, characterized by infinite density according to general relativity. The event horizon, on the other hand, denotes the boundary beyond which matter and energy cannot escape the gravitational pull. Kerr, rotating black hole. Rotating black holes, known as Kerr black holes, possess the intriguing characteristic of rotation. This rotation introduces additional components that facilitate the study and comprehension of black holes, making their discovery relatively easier. Components of a rotating black hole include singularity, located at the center. The singularity represents the point of infinite density where all matter and energy. Here's the continuation of the previous response. Singularity, located at the center. The singularity represents the point of infinite density where all matter and energy are concentrated. In a rotating black hole, the singularity takes the form of a rotating ring or disc-shaped singularity, known as a ring singularity or a Kerr singularity. Ergosphere. Surrounding the rotating black hole, there is a region called the ergosphere. In this region, space-time is dragged along with the rotation of the black hole. As a result, objects within the ergosphere are forced to rotate in the same direction as the black hole. The ergosphere plays a crucial role in extracting energy from the black hole through a process called the Penrose process. Event horizon. Similar to the non-rotating black hole, the rotating black hole also has an event horizon. It is the boundary beyond which nothing, including light, can escape the gravitational pull of the black hole. However, the event horizon of a rotating black hole is slightly different from a non-rotating black hole and is referred to as the static limit. Inside the static limit, space is dragged by the rotation of the black hole, affecting the movement of objects and light. Accretion disk. Around a rotating black hole, matter from its surroundings can form an accretion disk. The accretion disk consists of gas, dust, and other debris that is gradually pulled into the black hole due to its strong gravitational force. The material in the accretion disk heats up and emits intense radiation, making it visible to observation. Studying black holes. Since black holes themselves are invisible, scientists rely on indirect observations and theoretical models to study them. Some methods used for studying black holes include: 1. Observing accretion disks. By observing the intense radiation emitted from the accretion disks around black holes, scientists can gather valuable information about the presence and properties of black holes. Different wavelengths of light, such as X-rays and radio waves, provide insights into the behavior and dynamics of matter falling into the black hole. 2. Gravitational waves. Gravitational waves are ripples in spacetime caused by the acceleration of massive objects. The detection of gravitational waves from the merger of black holes has provided direct evidence of their existence and has helped to determine their masses and properties. 3. Effects on surrounding objects. The gravitational pull of a black hole affects the motion of nearby objects, such as stars or gas clouds. By studying the motion and behavior of these objects, scientists can infer the presence and characteristics of a black hole. 4. Simulations and theoretical models. Scientists use computer simulations and theoretical models based on general relativity to understand the formation, behavior, and properties of black holes. These models help to predict and explain various phenomena associated with black holes, such as the dynamics of accretion disks, the emission of jets, and the evolution of black hole mergers. Black holes continue to be a fascinating subject of study in astrophysics and cosmology. Through ongoing research and technological advancements, scientists hope to uncover more secrets about these enigmatic cosmic entities and expand our understanding of the universe.
The Hubble Space Telescope, an extraordinary marvel of human ingenuity, has silently observed the beauty and grandeur of the universe for over 3 decades. Since its launch in 1990, this remarkable piece of technology has gifted us with a collection of breathtaking images that allow us to peer deep into the realms of space and time. Join us now as we embark on an awe-inspiring journey through the cosmos with the top 10 most beautiful and mind-blowing images captured by the Hubble Space Telescope. Pillars of Creation. Pillars of Creation. This iconic image of the Eagle Nebula showcases towering columns of interstellar gas and dust where new stars are born. The ethereal beauty and delicate structures captured in this image serve as a testament to the ongoing cosmic cycle of creation. Hubble Ultra Deep Field. Hubble Ultra Deep Field. In this awe-inspiring image, Hubble stared at a seemingly empty patch of the sky for over 11 days, revealing thousands of galaxies. Each speck of light represents a distant galaxy, some of which existed when the universe was just a fraction of its current age. It reminds us of the vastness and diversity of our universe. Horsehead Nebula. Horsehead Nebula. This striking image reveals the silhouette of a dark cloud resembling a horse's head against a backdrop of glowing gas and stars. The Horsehead Nebula is a favorite among astrophotographers and serves as a testament to the wonders hidden within our Milky Way galaxy. The video continues with a scientific visualization of a flight into the infrared horsehead. The computer graphics model is intended to be scientifically reasonable, but not fully accurate. This new infrared image has been released to celebrate 23 years of the NASA ESA Hubble Space Telescope. The data in this video come from Hubble's Wide Field Camera 3, supplemented by ground-based observations from the European Southern Observatory's Visible and Infrared Survey Telescope for Astronomy, VISTA. Sombrero Galaxy. This stunning image captures the grandeur of the Sombrero Galaxy, a spiral galaxy located 28 million light-years away. The dark dust lane across its bright core gives it the appearance of a wide-brimmed hat, earning it its name. Located in the constellation Virgo at a distance of approximately 29.3 plus or minus 1.6 million light-years from Earth, 8.98 plus or minus 0.49 million parsecs. Its diameter is about 50,000 light-years, about 15,000 parsecs, which is about 30% of the diameter of the Milky Way. Hubble's Variable Nebula. This image showcases the glowing gas and dust clouds of the Hubble's Variable Nebula. Named after the telescope that discovered it. The intricate details and vibrant colors captured here are a testament to the intricate interplay between stars and their surrounding nebulae. Butterfly Nebula, also known as the Twin Jet Nebula, this mesmerizing image captures the dying moments of a sun-like star. The intricate, symmetrical patterns resembling butterfly wings are created by the stellar wind as it interacts with the surrounding gas. Cartwheel Galaxy. This captivating image reveals a galaxy with a distinct cartwheel shape. It is the result of a collision between two galaxies, sending ripples of gas, dust, and star formation rippling through the cosmos. The Crab Nebula is indeed a fascinating and visually stunning object captured by the Hubble Space Telescope. It represents the remnants of a supernova explosion that occurred in the year 1054, which was observed and documented by Chinese astronomers. The image of the Crab Nebula reveals its intricate and colorful structure, characterized by swirling filaments of gas, dust, and energetic particles. These filaments are the result of shock waves from the original supernova blast interacting with the surrounding interstellar medium. At the center of the Crab Nebula, we find a pulsar, which is a type of neutron star. Neutron stars are incredibly dense and compact objects that form when massive stars undergo a supernova explosion. Pulsars are rapidly rotating neutron stars that emit beams of radiation from their magnetic poles. As the pulsar spins, these beams of radiation sweep across our line of sight, causing the pulsar to appear to pulse or blink with regular intervals. Cat's Eye Nebula. The Cat's Eye Nebula presents a fascinating look at the final stages of a dying star. The concentric rings of glowing gas and dust resemble a cat's eye, hence its name, and remind us of the dynamic nature of the universe. Whirlpool Galaxy. This spectacular image captures the beauty of a classic spiral galaxy, the Whirlpool Galaxy, located approximately 31 million light-years away. Its graceful spiral arms and the presence of a companion galaxy create a mesmerizing celestial dance. These 10 celestial masterpieces from the Hubble Space Telescope provide a glimpse into the wonders of the universe and our place within it. They serve as a reminder of the vastness, complexity, and beauty that exist beyond our own world, inviting us to explore, question, and marvel at the mysteries that await us in the cosmos. Hubble, the iconic space telescope, has been a prolific observer since its mission began in 1990, capturing over 1.5 million observations. The wealth of data collected by astronomers using Hubble has resulted in an impressive output of scientific knowledge, with more than 19,000 scientific papers published based on Hubble data. This makes Hubble one of the most productive scientific instruments ever constructed, and its contributions to research have been recognized by its papers being cited over 1.1 million times. While Hubble doesn't physically travel to stars, planets, or galaxies, It captures mesmerizing images of these celestial objects as it orbits around Earth at a speed of approximately 17,000 miles per hour. It has completed numerous orbits, covering a distance of over 4 billion miles along its circular low Earth orbit, which currently sits at an altitude of about 340 miles.